It's time for this evening's Celestial Radio 3 in concert, live from the Barbican in London. It's presented by Penny Gore.
Welcome to the Barbican Hall for a celebratory evening with the BBC Symphony Orchestra. Conducted by Ben Gernon, they'll be playing a work that had its first complete performance at the Queen's Hall before a specially invited audience exactly 100 years ago to this very day, the 29th of September 1918, Gustav Holst's suite, The Planets. But we're not just hearing Holst's music tonight. Joining the orchestra on stage will be Professor Brian Cox to interpret and explain the scientific background and the latest research and thinking for each of the planets depicted in Holst's suite. Mars, Venus, Mercury and Jupiter in part one of the concert, and after the interval, Saturn, Uranus and Neptune. Now, not all of that music was heard when the work had its first tentative public outing in 1919. It was decided that all 7 movements were just too much for a paying audience to experience in the face of the overwhelming force of Holst's daring musical language. It was the conductor Adrian Bolt who made the decision to truncate the score to only 5 movements. But he'd also been the conductor of that first complete performance for an invited audience the year before, the occasion which Holst himself regarded as the true premiere. Now, it's not completely clear when Holst started work on the suite, or exactly why, but he might have been mulling it over for a couple of years, at least by the time he began sketching out the first movement, Mars, in 1914. As for the subject matter, Holst had been interested in astrology for some time. He discussed it with his travelling companions on a trip to Spain in 1913, and he discovered that one of them, the writer Clifford Bax, shared his fascination, much to the annoyance of Bax's brother Arnold and their fellow composer Balfour Gardner, who found that astrology dominated the conversation from that point onwards. And you can read more about Holst's interest in astrology if you follow the links on the Radio 3 website. Well, to begin tonight's concert, we'll hear Professor Brian Cox's introductions interspersed with the first 4 of the planets. Mars, the bringer of war, was a controversial movement with reviewers right from the start. And while it's sometimes assumed from its title and its relentless, implacable force that it was a comment on the horrors of the First World War, Holst actually finished writing it before hostilities broke out in August 1914. It's followed by Venus, the bringer of peace, its serene gentleness in deliberate contrast to the pitiless, driving rhythms of Mars. Mercury, the winged messenger, is effectively a scherzo, its scoring acclaimed as a triumph for Holst. And then Jupiter, the bringer of jollity, marks the halfway point in our planetary adventure tonight. Here in the hall, we'll be seeing a selection of stunning images from NASA, the Japan Aerospace Exploration Agency and the European Space Agency. And you can find a gallery of some of those images by going to the orchestra's website at bbc.co.uk/Symphony Orchestra. And that very large orchestra is on stage now. Leader Igor Yosefovich is already with the players, just putting the finishing touches to the tuning. Darkness descends, the interior of the Barbican Hall transformed into a night sky strewn with hundreds, if not thousands, of tiny twinkling stars. And coming on stage now, Ben Gernon with Professor Brian Cox.
"100 years ago tonight, Gustav Holst's masterpiece, The Planet, was performed for the first time. Holst planets were characterized by their astrological and mythological characters. So Mars, the bringer of war; Venus, the bringer of peace; Neptune, the mystic. The aim of tonight's performance is to place Holst's work in a different context, to step beyond the astrology and mythology, and to explore how the music changes if we listen today, with the luxury of 100 years of scientific discovery, and also if we listen in today's social and political context. You see, composers like Holst were involved in and contributed to the political and intellectual arguments of the day. Holst was on the left of politics. He taught at the newly formed Morley College in South London, which was founded to bring education to the working classes. And he was also a spiritual man. He was interested in Eastern philosophy. He learnt Sanskrit, and his music had a strong Indian influence. Now, he was writing the planets during the First World War and just before the First World War, a time of great social and economic and geopolitical instability. He volunteered for military service, but was not accepted due to his poor health. His character, his interests, and his political ideas are reflected in the planets. Precisely how, of course, is open to interpretation. That is the point of great art. But an interpretation I find interesting is that the planets can be seen as an intellectual journey, informed by Holst's socialism and his attraction to Eastern mysticism. In fact, the director Tony Palmer, in his film on Holst, wrote that in this context, the planets begins to make sense, not as an astrological chart a la Mystic Meg, but as a pilgrim's progress from the ferocity of industrial capitalism, represented by Mars, towards a karma of enlightenment, represented by Neptune. Now, tonight I'm not interested in arguing for this or indeed any other particular interpretation, but what I am interested in is how the work might suggest new ideas when set in a 21st century context, alongside the images and the understanding of the solar system to which we now have access. Mars, as Holst would have known it, was not a well-resolved planet, if you like. The photograph behind me is a photograph taken by a telescope that was commissioned in 1917. So in fact, just after Holst had written the piece. State-of-the-art, 100-inch Mount Wilson telescope in the United States. And what you see is a fuzzy blob. You can see something on the surface. You can see polar caps, the north and south polar caps. You can see dark markings on the surface. And at the time, even reputable astronomers mistook those markings for perhaps signs of vegetation. Astronomers like Percival Lowell argued that what he was seeing were canals on the surface of Mars, bringing meltwater from the poles down to arid equatorial cities, imagining a civilization on the planet. Of course, H.G. Wells had written, "The War of the Worlds, they gaze upon us with envious eyes." So Mars at the time was a mysterious world, and perhaps in a sense a mirror for our dreams and nightmares. It was a world where we could imagine living things, maybe inviting, maybe threatening. That image of Mars was dashed when we went there with spacecraft. The first spacecraft to fly past was in 1965, the Mariner 4 spacecraft. And it sent back grainy images of the surface, but they were images that looked much more like our moon than our more inviting planet Earth. And this came as a shock. It's surprising, actually. President Lyndon Johnson, president at the time, reflected. He said, it just may be, that life as we know it, with its humanity, is more unique than we may have thought. Sort of existential reflection from a politician. Powerful image. A magazine article at the time said something similar. It said, the shock, and I find this wonderful, the shock of these images from Mariner is caused not only by their denial of the terrestrial image of Mars, but by the revelation that there is no second chance, at least not in the solar system. So that's the shift, the twist, if you like, from an inviting planet in Holst's time, a planet that may support life, to a barren planet, and the shock that caused in the 1960s. If we move forward to today, we have much more beautiful high-resolution images of the planet. A fleet of spacecraft have visited. And we start to see a different world again. The first thing we see is a world of geological giants. You see a canyon spanning over half the face of the planet, which is called the Mariner Valley, after the Mariner spacecraft. The Grand Canyon here on Earth would fit into one of its side channels. It's also a planet of great volcanoes. In fact, the largest volcano in the solar system, Olympus Mons. This volcano, even though Mars is much smaller than Earth, is 2.5 times the height of Everest. And it would fit inside France, just about. So it's a very big volcano indeed. We start to see, when we fly over the polar caps, a landscape that looks more Earth-like, a landscape with ice, some of it carbon dioxide ice, but much of it frozen water ice. We see very clear evidence that rivers once flowed on Mars. We have good evidence that there were lakes, possibly even oceans on Mars. We've landed on Mars. As I speak, there's a rover called Curiosity, which is exploring an old, dry lake bed. It's found the signatures of organic molecules. It's found signatures of minerals that only form in the presence of standing water. So it seems clear, it is clear, that Mars was once a living world. Actually, Michael Mayer, who's the NASA lead scientist for Mars exploration, said that a fundamental question for these missions is whether Mars could have supported a habitable environment. From what we know now, the answer is yes. So we've built a picture up of Mars that tells us that it was Earth-like, perhaps 3.5 billion years ago, with rivers and oceans and seas. It was a living world. In a sense, it could have been a living world. Whether life began there, we don't know. But what's interesting is this changes our view of Mars again, because a planet like Mars that had water and still has water in the ice caps, and we now think in reservoirs subsurface, becomes a planet we could imagine visiting and even settling. It's a planet that has everything you need to build a civilization, to sustain life, to sustain human beings, minerals, water, and so on. So even if there weren't Martians 3.5 billion years ago, even if there aren't still Martian microbes today living subsurface, there will probably one day be Martians, because the Martians will be us. So in this context, Mars is not the bringer of war. It's the bringer of hope. Can we listen to Holst Mars and forget the deeply ingrained 20th century symbolism of mechanized warfare and the war of the worlds? Can we instead view Mars with optimism? Having survived the barbarism of the 20th century, our technology and our rockets are now freed to deliver perspective on our cosmic isolation and to provide a bridge to a future where humanity is no longer confined to a single world. Konstantin Tsiolkovsky, who's the father of Russian spaceflight, a legend in Russian space exploration, said a beautiful thing. I'm thinking of this image behind me. This is an image of Martian twilight. But in the twilight, you see a point of light. That's a photograph of Earth from the surface of Mars, a photograph of our planet from the surface of an alien world. Tsiolkovsky said, "The Earth is the cradle of mankind, but one cannot stay in the cradle forever." Venus, the bringer of peace. Holst would have known Venus well, as probably we all do. It's the evening or morning star, one of the brightest points of light in the sky. It's a planet that's very Earth-like in many ways. It's not too much closer to the sun. It orbits the sun once every 225 days. We orbit once every 365. It's about the same size as Earth. And this really led astronomers in Holst's time, and really through into the 1950s and 60s again, before we started to explore the planet, to consider it potentially Earth's twin. Just like Mars, it was considered to be a world which may harbour life. We can never see the ground from Earth. It's shrouded in clouds. And that added, I think, to this idea that Venus may be a tropical paradise. But as with Mars, we had a shock when we first started to point initially radio telescopes to Venus, which give us a sense of the temperature, and then began to fly space probes past the planet. We found that Venus is a scorched world. When spacecraft landed on the planet, Russian spacecraft in 1975, in particular a spacecraft called Verenin 9, it found a world that it could barely survive. It only lasted for around an hour. It measured temperatures of 465 degrees Celsius on the surface. The atmospheric pressure is 90 times the atmospheric pressure on Earth. That means if you or I stood on Venus, we would be toasted and then squashed. And if that didn't do for us, we would be dissolved because the clouds of Venus rain down sulfuric acid. So far from being an idyllic, beautiful bringer of peace, the goddess of love, Venus is the closest world to hell you could imagine. When we started peering through the clouds, as we've done with spacecraft, using radar, then we were able to map the surface. And we see a surface that is covered in volcanoes, far more volcanoes than any other planet in the solar system. An arid, scorched desert of a world. What's interesting, though, is that it seems that, again, like Mars, if we go back 2 billion, 3 billion, 3.5 billion years, Venus would have had water on the surface, may have been a habitable world, may even have given rise to life, may have been that paradise. But something went wrong on Venus. Those volcanoes pumped carbon dioxide, sulfur dioxide, greenhouse gases into the atmosphere. Venus doesn't have plate tectonics, continents that move like Earth. And so there was no way of getting those gases out again. The cycles of the planet ran away with themselves. A runaway greenhouse effect heated the planet up and destroyed it, certainly as a habitable world. So I think the lesson of Venus is that planets are not eternal. A planet that was once habitable, perhaps like the Earth, can become uninhabitable. A world that was once heaven can become hell. Earth has remained stable, a stable home for life, for almost 4 billion years, pretty much the entire age of the solar system. But Venus teaches us that such stability, which was necessary on our world for the emergence of a civilization whose cities light up the night, may not be so common across the universe. Venus, bringer of peace, becomes a requiem for a failed planet, and perhaps also a reflection on how rare places like Earth might be. Mercury, the winged messenger. There are spacecraft whose job it is to observe the sun. And one of them is called the Solar Dynamics Observatory. It sort of sits there and looks for solar flares and solar storms, watching how the sun behaves. But occasionally, those spacecraft capture something quite magical. They capture what's called a transit of Mercury, a small black dot tracing its way across the face of the star. These images, to me, are remarkable because they show you, in part, just how vast, how big the sun is. You can fit 1 million Earths inside our star. So compared to a planet, stars are overwhelming. Mercury sort of zips around the sun very fast. The winged messenger is a rather nice title because it's very close to the sun, but very difficult to get to. We didn't get a spacecraft into orbit around Mercury to take spectacular pictures as we have of the other planets until 2011. The reason for that is the sun creates what's called a gravitational well, and it's a rather good analogy. It's like a well. Imagine you throw a stone into a well, but you want it to stop and slow down about halfway down. It's very difficult. That's what it's like, dropping a spacecraft towards the sun from Earth to Mercury. The Mercury Messenger spacecraft, which is the first spacecraft we got into orbit around the planet, actually was launched in 2004. It took 7 years to get to Mercury. It had to fly around the Earth once, then go around Venus twice, and then around Mercury 3 times before it had slowed down enough to get into orbit. What it found was a world that, well, we knew it would be hot. It's close to the sun. It's about 430 degrees Celsius by day on the surface. However, because there's no atmosphere on Mercury, it drops to about minus 180 degrees Celsius at night. So it's a world of extremes. Zips round the sun once every 88 days. But bizarrely, because of the way it spins and rotates, a day on Mercury is 2 years long, which is a very strange thing. We also knew, and this is one of the reasons we wanted to go there, that Mercury is a strange planet. It's got a very strong magnetic field, notwithstanding the fact that it's very small. It's smaller than some of the moons of Jupiter and Saturn we'll meet later on this evening. So it's got a huge iron core. It's almost, in some sense, like a stripped-away planetary core that hasn't grown. Messenger also found traces of what astronomers call volatiles on the surface, things like potassium. Now that's interesting because potassium is only expected to be found on planets that form further out in the solar system. They're called volatiles for a reason. They boil away when they're close to the sun. So we now think that Mercury formed much further away from the sun than the position where it orbits today. So again, the winged messenger seems to be rather apt. Mercury has shifted a great deal in its orbit during the history of the solar system. And in fact, our simulations suggest that it's at least possible that Mercury will shift again and fly out into the outer solar system, perhaps even be lost to the solar system to interstellar space. So Mercury illustrates another important point about solar systems. It's not only single planets that are unstable, like Venus, that change over time periods of hundreds of millions or billions of years. Solar systems themselves are complex systems that can be reconfigured. Entire planets can shift in their orbits. The solar system is not a piece of eternal clockwork crafted by the gods, but a dynamic, living, and evolving place. Jupiter, the bringer of jollity. Jupiter is a dominant planet in the solar system, in a sense. It's 2.5 times the mass of all the other planets and moons combined. And that means that it is really the only object in the solar system, other than the Sun, that has a quite profound gravitational influence on the rest of the system. For example, the asteroid that wiped out the dinosaurs here on Earth 66 million years ago is likely, or at least it's possible, that it was deflected into or onto a collision course with Earth by Jupiter. Now, that is a profound influence. If that asteroid hadn't hit, then it's certain that human beings wouldn't have evolved. So in that sense, we get to thank Jupiter for our very existence. Jupiter is a creator and destroyer of worlds. We have a spacecraft in orbit around Jupiter now called Juno, which is sending back the most remarkable images of the planet. It's a spacecraft that for the first time orbits such that it can see the poles, the north and south pole of Jupiter. And they look radically different to the Jupiter that we all know. I think the banded clouds of red and orange and yellow and white. You look at the poles, they look bluer. They're swirling masses of complex clouds. When you zoom in, you see images of clouds that look almost like Impressionist paintings. Jupiter is really a planet. It's a whole atmosphere as a planet, and all the more beautiful for that. Juno, by the way, can fly within about 10,000 miles of the cloud tops to get these spectacular images. The storm that we're probably most aware of or all know on Jupiter is the Great Red Spot. It is a storm system, although it's been there for at least 350 years, as long as we've had telescopes. But it is shrinking. So when Galileo saw the storm system, you could have lined up 3 Earths in that spot. Gives you a sense of scale of Jupiter. Now it's shrunk. You could only fit about 2 Earths across the diameter, but it's still a big and long-lived storm. Jupiter is a fascinating world in itself, but equally fascinating is its own mini solar system. Its moons, over 70 moons. And the 4 brightest, which you can see through an amateur telescope or even powerful binoculars, were discovered by Galileo. They're called the Galilean satellites. These moons played an extremely important role in the history of human thought because they confirmed to Galileo, or persuaded him he may be on the right track, when he considered that the Earth is not the center of all things. The Earth, we are not the center of the universe. Because when you look at Jupiter through a telescope, it's obvious that those moons are in orbit around it and not around us. So things exist in nature that do not orbit around us here on Earth. A powerful realization. This image that you can see here, by the way, is a video of the approach of Galileo to Jupiter. You see the moons orbiting around. Those moons are in themselves worlds with their own characters. Io is the most volcanically active body in the solar system. Every time we fly a spacecraft past this moon, we see a volcano erupting somewhere. It's yellow and orange, covered in sulfurous deposits from the volcanoes. It turns itself inside out with volcanic activity. Ganymede is a planetary-sized moon. It's bigger than the planet Mercury. So if it was orbiting the sun, it would easily be considered a planet. So large, it has its own magnetic field. And then a rather magical world called Europa. Europa is an ice moon, a moon covered in a shell of frozen water ice. But we know that beneath that shell of water ice, there is an ocean of liquid salt water. It contains more water than all the oceans of the Earth combined. And so Europa may well be a home for life. And this is the focus of the next 10, 20 years of space missions. Could there be Jovians living in the oceans of Europa? It's certainly possible. Now, Holst would have known about the moons as points of light. He would have known that Jupiter had clouds, but not much else. When we step out beyond Mercury and Venus and Earth and Mars into the realm of the gas giants, the distances in the solar system become unimaginably vast. Jupiter is 500 million miles from Earth. We first visited it in 1973 and 1974 with 2 quite primitive spacecraft called Pioneers 10 and 11. But really, we got our first pictures of the planet, and particularly the moons, from 2 iconic spacecraft. I'll keep returning to them tonight, Voyager 1 and Voyager 2. These spacecraft were launched in 1977. They arrived at Jupiter in 1979. We are still in touch with them both today, 41 years after they were launched. Voyager 1 is 13.3 billion miles away from Earth in interstellar space. It's a tiny little thing. I want to show you this photograph of me standing in front of a scale model of it at JPL in California. What you see is a spacecraft that's about as big as a bus, if that, perhaps a large family car. Transmitter of about 16 watts. And yet this 1970s technology is still speaking to us today. It's even got a tape recorder on it, by the way, that records the data and plays it back to Earth. It's a remarkable engineering achievement. Voyager 1 visited Jupiter, went on to Saturn, and then went off into interstellar space. And on Valentine's Day 1990, as it was on its way out of the solar system, it took what I think is the most famous image, certainly of Earth in the history of space exploration, when it was 4 billion miles from home. It's called the pale blue dot image. Now, the image itself looks a bit blurry. There are coloured stripes crossing the image, which are lens flare, because from 4 billion miles away, the Earth is very close to the sun. But if you look carefully, in a red stripe, you'll see a point of light, which is our planet, the Earth, the pale blue dot. Carl Sagan, who's one of my great heroes, wrote a very powerful piece of prose about this image, reflecting on what it tells us about our place in the universe. The Earth, he wrote, is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors, so that in glory and in triumph they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this dot on the scarcely distinguishable inhabitants of some other corner of the dot. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds, our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe are challenged by this point of pale light. This idea that Jupiter might represent humility, the beginnings of the realization that we are perhaps more fragile, smaller, and more interdependent, both with each other and the wider universe, than we often like to imagine, I find fascinating in the context of tonight's performance. Holst Jupiter, after all, contains one of the most well-known passages in classical music, the lyrical section that became the patriotic hymn, I Vow to Thee, My Country. Patriotism, the love of country. These are important ideas. They were important to Holst. But so too is the idea that we are one civilization, living together precariously on one planet in an ever-changing and always challenging universe. The most important ideas, I think, often emerge from the consideration of apparently contradictory concepts. If we are to avoid Sagan's endless cruelties of history, we must find a way to reconcile our affection for our countries with our responsibility to protect our homeworld by working together. It's my view that the exploration of space has helped deliver this perspective.
Jupiter, the bringer of jollity, with the middle section that became the song I Vow to Thee, My Country. Holst made a very tiny arrangement to the melody, and as a hymn tune it's known as Thaxted, the name of the village in Essex where Holst lived for many years. And incidentally, the words for I Vow to Thee, My Country were written by Cecil Spring Rice, whose daughter was a pupil at St Paul's Girls' School, where Holst, of course, was director of music. Well, that fourth planet in Holst's suite brings us to the interval in tonight's live concert from the Barbican Hall. The BBC Symphony Orchestra is conducted by Ben Gernon, with scientific commentary by Professor Brian Cox, bringing the planets so vividly to life. And the television cameras are here tonight. You'll be able to see the performance on BBC Two next spring as part of a major BBC series, Our Classical Century, charting 100 years of classical music, with programmes on television and here on BBC Radio 3. Well, in 20 minutes, we'll be completing Holst's suite with the remaining 3 planets, Saturn, Uranus and Neptune. And between now and then, we won't be straying too far from the heavens, with a mixtape dream sequence of planetary and astrologically inspired music, interwoven with works influenced by Holst's planets. And starting with Philip Langridge singing a little-known song by the composer, one of Holst's 12 Humbert Wolf settings, describing a remote red star in the constellation of Orion.
There is nothing that joys or grieves the unstirred multitude of leaves, nor ghost of evil or good haunts the gold multitude on Betelgeuse. And birth they do not use, nor death
Kaya Sariaho's setting of a text by Friedrich Hölderlin, Conviction. The Norwegian soloist choir was directed by Greta Pedersen, awakening us from this planetary dream sequence in which you also heard pieces by Frank Zappa, John Williams, George Crumb, Jean-Ferry Rebel and Gustav Holst. Welcome back from me, Penny Gore, to the Barbican Hall, where Professor Brian Cox will be rejoining the BBC Symphony Orchestra and conductor Ben Gernon in a couple of minutes to resume tonight's live Centenary performance of Holst's suite, The Planets, which was heard complete for the first time at the Queen's Hall in London on the 29th of September 1918. Holst had started work on the score some 5 years before, fitting the work around his duties as Director of Music at St Paul's Girls' School in Hammersmith. As the project gathered pace, his pupils and colleagues were co-opted into helping out to play through the piano scores and act as copyists for the full score. In 1968, Sir Adrian Boult, the work's first conductor, remembered the excitement and the pressure of that first performance.
One day in the late summer of 1918, a breathless, wide-eyed figure appeared in the doorway of the office attached to the War Office, where I was then working. "Adrian, I have got to go to Salonika for the YMCA. Balfour Gardner, bless him, has given me a parting present consisting of Queen's Hall, full of the Queen's Hall Orchestra, for the whole of a Sunday morning. We are going to do the planets, and you've got to conduct." My knowledge of the planets had then been one hearing of an admirable two-piano version played by the arrangers, Miss Valley Lasker and Miss Nora Day, both of whom were on Gustav Holst's staff at St Paul's Girls' School. Every available spare minute of every available girl at St Paul's was then devoted to copying the parts and rehearsing the select choir of girls and staff. As the copying of each movement was finished, the precious score was sent to me, and I did my best in odd moments, of which there were not many in those end-of-the-war days, to get this very striking music into my head. Needless to say, I was helped on several occasions by hearing some more performances on two pianos. The Sunday morning came, September the 29th, 1918. There was the Queen's Hall Orchestra, led by the veteran Maurice Sons, and an audience accumulated through the morning, which included most of the critics of London, the whole of St Paul's Girls' School for several generations, and for good measure, some very distinguished musicians like Sir Henry Wood. We rehearsed for an hour and 3/4, and the performance took place punctually at 12 o'clock. And I think it can be claimed that the result put the planets on the map then and there.
Sir Adrian Boult, founder of the BBC Symphony Orchestra, reminiscing in 1968 about the momentous first complete performance of Holst's suite, The Planets, which he conducted exactly a century ago today. Well, Professor Brian Cox will begin part 2 of tonight's performance by the BBC Symphony Orchestra by talking about Saturn, characterised in Holst's score as the bringer of old age. The composer said this was his own favourite movement of all 7, evoking the inexorable passing of time, yet ending with a sense of serene acceptance. Uranus the Magician led many reviewers to draw comparisons with The Sorcerer's Apprentice by Ducasse, although Holst's daughter Imogen believed that its concept was recycled from an earlier piece, the Fantastes Suite, performed just once in 1912 and then withdrawn. And the final movement is Neptune the Mystic, with its wordless choir of offstage female voices receding gradually into infinity. A role assigned at the premiere to Holst pupils at St Paul's Girls' School, but performed tonight by the women of the BBC Symphony Chorus. And returning now to the Barbican Hall stage, Ben Gernon and Professor Brian Cox.
Saturn, the bringer of old age. Saturn is, I suppose, the most iconic planet made famous by its ring system. They are an intricate system, beautifully complex. Every time we send a space probe to Saturn, we get even more stunning images of the rings. They are made of a very simple thing: ice, water ice, sprinkled around the planet, snowflakes, if you like. A friend of mine who worked on the Cassini probe, which has taken the most spectacular images of Saturn, said that it's like, you know, when you get a magnet and sprinkle iron filings over it and you can see the magnetic field. Well, in the same way, it's like some deity has sprinkled snowflakes over Saturn so you can see the gravitational field. That complex gravitational field is created by the moons, over 60 large moons and countless hundreds of smaller moons, which make sort of almost ripples in the gravitational field around the planet. They look impossibly thin, and they are impossibly thin. They're in fact only around 10 meters thick. So they would fit comfortably inside this auditorium. And they also, we found, are most likely young. Now that's interesting, perhaps only tens of millions of years old. What we think happened was that a moon came close to the planets, probably in collision with another moon, or perhaps a gravitational interaction with another moon, and then dissociated and broke up to form the rings. It's possible that they weren't there when the dinosaurs were on Earth. So if the dinosaurs had invented telescopes and looked up at Saturn, they may well not have seen that planet that we see today. Saturn is, as with Jupiter, an interesting planet in itself, but also interesting because of its mini solar system, its moons. It has one of the largest moons in the solar system, Titan, which in this image you see above the ring plane, and you can also see the delicacy, the thinness of the rings in this photograph. Titan is, again, like Ganymede around Jupiter, a moon that would be called a planet if it were in orbit around the sun. It's got a very thick atmosphere, and usually it's covered in cloud, just like Venus, but occasionally those clouds clear, and then we see sometimes sunlight glinting off the surface. Glinting off what? Well, it's liquid. Titan is the only object in the solar system other than Earth that has liquid on its surface, but it's freezing cold, a long way from the sun, minus 180 degrees Celsius or so. So that liquid is not water. It's liquid methane, liquefied natural gas. So this moon has lakes and seas and rivers of methane. It has methane rain and methane snow, a methanological cycle in the same way that Earth has a hydrological cycle. We also think that it may have liquid water below the surface. So again, this is an interesting moon in the context of life. There now, possibly, there in the future, when the sun warms up and warms the surface of Titan, who knows? But there is another moon around Saturn that is equally, even perhaps more intriguing. And that's a strange thing because it's a tiny moon. It's a moon called Enceladus. It's only about 300 miles in diameter. Now, what we thought before we began to send spacecraft out into the solar system was that small moons undoubtedly would be barren, rocky, dull worlds, geologically inactive. But again, we are surprised it turns out not to be the case. Enceladus is an active world. It has distinctive surface features, sort of stripes of turquoise, which have become known as the tiger stripes. And when the Cassini spacecraft flew close to Enceladus, it was able to take images which revealed that activity. What we see on Enceladus are fountains of ice rising up from the surface and disappearing off into space. Beautiful, but what we think is causing those fountains is even more beautiful. We're now, I would say, certain that there are lakes of liquid water below the surface of Enceladus. And on the floors of those lakes, we think there are geological systems called hydrothermal vents. So you get energy from inside the moon, the interior, heating up water and ultimately spraying out into space to make ice crystals that we see in our photographs. Now that is fascinating because we think that one of the prime candidates for the origin of life on Earth 3.8 billion years ago are hydrothermal vent systems, where you get energy in contact with rock, in contact with minerals, and that transition, which must have happened somewhere, almost certainly happened on Earth, that transition from geochemistry to biochemistry happened. Those conditions, we think, are present on this moon today. So this moon is one of the prime candidates to look for life beyond Earth in the solar system. And when we look at images of Saturn, in particular the images Cassini captured, which are backlit by the sun. So you see the sun shrouded by the body of the planet, but the sunlight illuminating the rings. There is a diffuse ring far away from Saturn known as the E-ring, which is created by the ice fountains of Enceladus. So it's a tiny moon, but with a potentially dramatic impact, both in terms of the visuals of Saturn, the creation of the rings, but also philosophically, intellectually, as a possible home for life. So Saturn, the bringer of old age, in Holst's mind, is not a world enjoying a sedate old age. It's a dynamic world, a fast-changing system, constantly rejuvenating, raging against the dying of the light. Its rings are young, perhaps tens of millions of years old, and its moons, in particular, tiny Enceladus, are perhaps engaged in the most spectacular rejuvenation of all. That natural transformation of rock and minerals and water and heat into living matter. The transition from geochemistry to biochemistry that brings meaning to the universe. We are now entering the mysterious dark frontier of the solar system. Uranus, the magician. These worlds would have been absolutely unfamiliar to Holst, no more than points of light, because they are so far away. When we look at Uranus through our most powerful telescopes on Earth, and here you see it through the VLT, the Very Large Telescope, it's powerful. You see that it's a planet you can see some surface features on, or cloud features. It's a blue planet with white clouds, high altitude clouds, and also moons. 4 moons are visible in this VLT image. The image looks odd, though, because the moons are aligned vertically. We're used to seeing moons and planetary systems sort of aligned horizontally, with the moons orbiting around the equator of the planet. But in this image, the planet appears to be tipped up on its side, and that's because it is. That's one of the most mysterious things about Uranus. It is tipped over. It orbits the sun in sort of a corkscrew shape, with its poles leading the way. Now, why? It's almost certain that Uranus must have been hit by a large planet at some point in the very distant past, 4.5 billion years ago, during the formation of the solar system, which tipped it over. Also from Earth-based telescopes, we can see a bit more detail. It's an image from the Keck telescope in Hawaii. You can see that Uranus has a ring system. It's nowhere near as spectacular as Saturn's rings, but there are rings nonetheless. Now, it has very strange seasons because of its tilt, its 90-degree tilt, essentially, and its strange long orbit. The North Pole of Uranus spends 21 years in the darkness in winter, followed by 21 years in the light in summer. It takes 84 years to go once around the sun. Now, the only spacecraft to make it this far out was Voyager 2. The spacecraft I talked about earlier on, the thing with a small transmitter about the size of a bus with a tape recorder on it. It made it out there on the 25th of January 1986. So that's 9 years after it was launched. Very difficult for it to take photographs. It could take photographs of the planet, which was relatively featureless, actually, when Voyager passed through the system. But the moons are a different matter. The sunlight out there is only 1/400th of the intensity of sunlight here on Earth. Temperatures are very low. The cloud tops, minus 224 degrees Celsius. But there are very powerful winds there. The winds at the equator move at 200 miles per hour, but in the opposite direction to its spin. Very strange. But as you move up through the tropics towards the poles, the winds reverse direction and blow in excess of 500 miles per hour. So even though there's not much energy falling on the planet, it does have violent, powerful weather systems. The moons are beautifully named, actually. They're named after spirits, Shakespearean spirits, and spirits in English literature. So Umbriel, Ariel, Miranda. The photographs, because light is so dim and Voyager was traveling so fast, are quite blurry sometimes. There's a photograph of Umbriel. You don't see much detail. But I like photographs of Miranda, which is a moon that seems to have been assembled by some kind of drunken god on their day off. It's all bits of terrain stuck together at all different angles, certainly because Miranda was hit sometime in the past and then reformed under its own gravitational force. So the Uranus system is a strange system. It's a long way away from the Earth. Voyager only spent 5.5 hours in the system as it traveled through, taking these, the only photographs we have from near the planet, and then left, leaving the strange, tilted magician behind in the twilight. In summer 1989, Voyager 2 arrived at Neptune, the true frozen outpost of the solar system, a planet that's known as an ice giant, dwarfs the Earth, but made, just like Jupiter and Saturn, Uranus, primarily out of gas. It is a a strange world as Uranus is. It's similar in many ways, a blue world. More features on the planet were visible when Voyager passed by. It's still very cold, minus 220 degrees or so at the cloud tops. But Neptune produces some heat internally. And so at some point, as you dive below the clouds and the pressures increase, there is, we expect, a zone where you could find clouds of water, perhaps liquid water. Neptune is a world of violent winds. We saw high-altitude clouds as Voyager passed by, clouds of methane crystals, supersonic winds that blow at speeds of up to 1,200 miles per hour. So despite its serene appearance, Neptune is certainly a violent world, at least in terms of its weather. It has moons, and this is one of the stories, I think, of tonight, the stories of space exploration. The moons turned out to be more interesting than we could possibly imagine. The largest moon is a moon called Triton, and this is so far away from the sun, very little energy falls on its surface, but we saw activity. We saw geysers erupting into the air, geysers of nitrogen sprinkling dark material downwind onto its surface, processes that we don't yet fully understand, leaving streaks across the surface of the moon. But as Voyager left the Neptunian system, it took one of the most iconic images in the history of space exploration. I think actually it's my personal favorite. This single photograph of crescent Neptune and crescent Triton looking back into the solar system from Voyager 2 as it left into interstellar space, I think enhances the music more than words. It is an image from the frozen edge of our solar system, 3 billion miles from Earth. A world of ice, 230 degrees below zero, orbiting a blue planet of storms. These two worlds remained unseen for 4.5 billion years after their formation, until our tiny emissary from Earth passed by on its way to interstellar space. It's a twilight gateway to the stars that lingers in the imagination as the choir fades away. Now, I suggested at the beginning of tonight's performance that I hope new ideas would emerge from the synthesis between Holst's music and the images and scientific discoveries we've made since the first performance of the planets, precisely 100 years ago today, on the 29th of September, 1918. And for me, they have. There are billions of planets beyond our solar system orbiting around the 200 billion stars in the Milky Way galaxy and in the billions of galaxies beyond. But we've discovered that solar systems and their planets are not necessarily, or even perhaps usually, stable on the timescales necessary to allow complex life and civilizations to evolve. So we, the human race, might be extremely fortunate to exist, and therefore we may be indescribably rare and therefore precious. I mean, imagine that there are no other civilizations in our galaxy. There would then be no music amongst the stars. Holst tells us through his music that it's up to us how we navigate our problems, to choose how, or even if, we want to undertake the journey from Mars to Neptune, from war to enlightenment. His message is amplified, I think, 100-fold by an understanding of our place in the universe, an understanding of the fragility and value of humanity, living as we do together on a small world accompanied by our 7 planetary companions adrift in the dark.
The distant, receding sounds of wordless female voices bringing Holst's suite to the planets to a mystical end. A musical and philosophical progression from the driving force of Mars through to this final celestial fading away and ending this centenary performance given by the BBC Symphony Orchestra, conductor Ben Gernon, and with the scientific commentary illuminating each planet given by Professor Brian Cox, and the women's voices of the BBC Symphony Chorus right at the end. Their director, Neil Ferris. Professor Brian Cox, that great enthusiast and champion for the understanding of science, coming back on stage now with Ben Gernon. And a great cheer for him. As you've heard tonight, he's so fascinated by the beauty and mystery of the universe. And in any spare moments around this afternoon's rehearsal, he was surrounded by a little knot of people, orchestra players and audience members in the rehearsal, keen to hear more from him. And the members of the BBC Symphony Orchestra standing now, Professor Brian Cox and Ben Gernon at the front of the stage, taking their bow. Members of the audience here at the Barbican Hall on their feet too. We've heard some amazing music and seen some amazing pictures as well. And you can head to the BBC Symphony Orchestra's website to see a gallery of some of those pictures. A 100 years ago exactly since the first complete performance of this piece, and recordings followed fairly quickly. Holst himself conducted several recordings of movements, culminating in a complete recording in 1926. Which eventually, very much later, was available on CD. And Neil Ferris on stage now, the director of the BBC Symphony Chorus, joining Brian Cox and Ben Gernon, and the BBC Symphony Orchestra standing, a huge orchestra, as I said earlier, including organ, 2 pairs of timpani, tenor tuba, 6 horns and 4 trumpets. Well, don't forget to visit the Radio 3 website to read more about Holst, the background to the piece, his interest in astrology, and a whole collection of music of the spheres there, including today's edition of Music Matters, reporting on a new project of 8 compositions based around the planets. For now, though, we're returning to Earth. Let's jet back to the Radio 3 studio and touchdown with Mark Forrest.
An effortless touchdown. Thank you, Penny. What a very different way to experience Holst's planets. 100 years to the day since the premiere.